So we've looked at how the sine graph is generated and what it looks like. So our sine graph looks like that, the wave, starting at 0 as we go through the angles up to 180 degrees, it goes up and then back down to 0, and then back to down and back up to 0 at 360. So that is one full revolution from 0 to 360. Now, as we keep on going through revolutions in the circle, that will repeat. So this wave repeats forever. And if we went backwards through our angles, it would also repeat in mirror image. So the sine function is y equals sine of the angle, usually x. So sine of x. But that has an invisible 1 in front of it, 1 sine x. And in front of the angle, there's an invisible 1 as well. Okay, so there's coefficients there that we haven't looked at yet. But how does the function change as the graph changes, and how does the graph change as the function changes? So I'm just going to track this black dotted line is our regular sine function, y equals sine of x. So looking at the equation on the left, y equals 1 sine 1x. If I change the number in front of the sine, what happens? So basically we're multiplying the value of sine of the angle by some number. So instead of multiplying by 1, I'm going to increase that, and look at what happens to the angle. Look at what happens to the graph. It stretches upward. Okay, so let's put it somewhere that I can kind of see it at around 2. Okay, so now look at the graph compared to the original sine graph. It still starts at 0, it still comes up to its peak, its maximum at 90 degrees, back to 0 at 180, down to its minimum at 270 degrees, and back to 0 at 360 degrees. The only difference is its maximum and minimum are much higher than the original graph. So this is called the amplitude of our graph, of our function. Okay, it's amplified upwards, it's stretched upwards. Okay, so it reaches higher and lower y values. Basically, if the sine of 90 is 1, if you times that by 2, you get 2. So if we double the sine of the angle, we increase the values by a factor of 2. And you'll notice now our range, the lowest to the highest, is now -2 to 2. But the axis of symmetry, the middle of the graph, still is the x-axis, or 0, y value of 0. So let's just put that back for a second to 1. Okay, what happens if I multiply the angle now? Okay, so I'll leave the amplitude as 1. But if I multiply the angle, so as we increase that, what is happening to the graph? It's compressing inwards. And as we decrease it, so as we go into fractions, it gets wider and wider and wider until it actually flattens at 0 and then flips upside down as we go to negatives. So if we had -1, it would be the same as the original sine graph, but upside down, flipped. So this changes our period. So the regular period of a sine graph is 360 degrees. As we do one full circle, the wave goes up, down, and back to the middle. So that's 360 degrees. So this number here changes the period. As we increase it, the period gets smaller, so it compresses the graph. So let's look at what happens if we change that number to 2. So we are compressing the graph by a factor of 2. So the period is now, for the red line, 180 degrees. It takes 180 degrees to do a full wave, up, down, and back to the middle. So the period is 180 degrees. Or in other words, that number is 2. We've doubled the angle. So we've doubled the number of repetitions. The normal sine graph does a full revolution from 0 to 360. So in 360 degrees, it does one full wave. Whereas our red line now does 2 full waves. So for it to do 2 full waves, the width of the wave must be halved. And if we increase that to 3, it would do 3 full waves. And the width of the wave would be divided by 3. So So that is your period of the graph. As we said, as it gets bigger, the number gets bigger, the graph gets narrower. As it goes into fractions, the graph gets wider. And in negatives, the graph flips upside down. So I'll put that back to where it was. Let's just look at the amplitude in a similar way. What happens if the amplitude goes into fractions? It obviously gets lower and lower and lower until when it goes into negatives, it again flips upside down. Okay, I'm going to skip the C number for now and look at what happens if I increase the D. So what I'm doing is adding a number to the end of the function. So basically I'm calculating the value of sine of whatever angle it is and then adding a number onto that. So for example, if sine of 90 in our original graph is 1, then I add 1 and I get sine of 90 is now 2. But in terms of the graph, what actually happens is it just moves up or down. So where my range of the original graph goes from -1 to 1 on the y-axis, if I move it up by 1 or add 1 onto the end, the range now goes from 0 to 2. So it moves all the numbers in the range up. Or in other words, it moves the axis of symmetry up. So the axis of symmetry, the middle of the graph, the original graph, is the x-axis, or 0, y value of 0, y equals 0. So if I move this upwards, now the middle of the graph is at y equals 1. That's the axis of symmetry of the graph. And so on. If I move it up here, y equals 2. And then it can go into negatives also.